evening and welcome. You know I wasn't going to leave you hanging, so just to make sure we understand a little bit more, I saw your faces, and I wanted to make sure we understand when we have the side angle case when we're dealing with triangles. These were the six cases that we had, and I want to make sure that we understand each one of the six cases. We did a problem with obtuse angles, and we tried to do a problem with acute angles. Not sure if it went over well, but we tried. So understand some of the things that we need in order to have a triangle, two triangles, or no triangle. We did the obtuse case, so let's talk about the acute case. We did this problem in class. With this problem, it kind of shows you what we needed to get where we needed. We have two sides, 20 and 11. And with all of that, we were able to find all the angles and all the sides. The reason why with that obtuse case right there is because A was greater than B. A was 20, B was 11, so therefore we have one triangle. If A was less than or equal to B, we would have had no triangles. That was the obtuse case. In the acute case here, actually let me erase this and go back over it again so you guys understand even more what's happening. So here in this acute case where our angle A is 51 degrees and A equals 3.5 and B equals 5. First off, let's draw our triangle. Well, let's draw pieces of the triangle. Let's draw the triangle to see what we'll end up with. So say, oh, that's not working well. All right, say we actually have a problem with looks like angles 51 degrees. A is 3.5 and B is equal to 5. Now, let me zoom in just a little bit so you can see and understand that we want a 51 degree angle right here. So this would be A. That means this corresponding side will be A. This is B right here. That means that the angle over here, if we can make a triangle, that would be B, and C would be up here, that would be C. But using all of those, we're trying to solve the C or see if we could solve it, right? Now, one of the important things to understand is that all of these triangles have a height, right? And if we split it right down the center like that, we form two right triangles. Now, one part that I want to show you is up here with each one of these cases. H equals B times sine A. We're actually going to use that with this. It might have been confusing when we did it in class, but hopefully this helps. So what happens is that since H equals that, and this is our right angle right here, B is our hypotenuse, H is one of the legs right here, right? So we just took the sine of 51 degrees. We end up with H over whatever B is, and B in this case is 5, right? So since that's the case, H equals 5 times the sine of 51, right? And from there, understand what that's going to give us. If you look here, we have 3.9. Okay, we have 3.9 right there. So that means that H is equal to 3.9. However, notice something. Remember in this problem that A equals 3.5, right? H equals, and that is not greater, but H, this is less than 3.9, which is, doesn't really matter all the other parts. But since that's less than, you understand that A is less than H. And if you go back up to the chart, in an acute case, if A is less than H, we have no triangle. And we are still able to find that from this part right here. So we'll call that no triangle. But we had to check to make sure because we weren't sure. All right, now down here, we can do a different problem. Say here, solve ABC with A equals 40 degrees, A equals 13, and B equals 16. Now this is the problem that we left off on and some of you got a little hung up on. But I will show you what happens with this problem. Now notice, since in this triangle, remember, we should find the height. In finding the height, that will tell us more about this triangle. All right. So finding this h will tell us what kind of triangle we're going to have. Now, in finding this height, remember, we're talking about 40 degrees. Since we have 40 degrees here, we could do sine 40. Whatever sine 40 degrees is, that's going to equal h over 16, right? Since now h over 16, meaning that you have 16 sine 40 equals h, meaning that h equals 10.28, right? So 10.28. Now, we have all of those. Notice that a itself, which is 13, is in between 16 and 10.28. So that means that A is in between H and B. And if we scroll all the way up, what does it mean for H to be in between H and B? That means you have two triangles. So since you have two triangles now, let's first I want to